In this video, we will examine nomenclature of alcohols and ethers. Alcohols can be considered to be derivatives of water, where one of the hydrogen atoms of water is replaced by a hydrocarbon, usually alkyl substituent. Alcohols are classified according to the degree of substitution of the carbon bonded to hydroxyl or OH group. So they are classified the same way as alkyl halide, according to the degree of carbon that is bonded to functional group. So general formula of primary alcohol is shown here, where carbon attached to hydroxyl group is attached to one other carbon. So that would be primary alcohol. An example of primary alcohol is ethanol, and you will see nomenclature or naming soon. Methyl group is also considered to be primary, or sometimes it's classified separately. So one carbon alcohol, methanol, is also considered to be primary alcohol. And note how we designate primary alcohols. We can put 1 degree of substitution in parentheses or write primary alcohol. If it's 1 degree in parentheses, again, just like alkyl halides or any other class of compounds, this is always read as primary. We don't call that 1st degree or 1 degree, it's always called primary. Secondary alcohols have carbon attached to functional group, hydroxyl group, attached to 2 other carbons. So general formula is given on the left and a couple of examples on the right. So those are secondary alcohols. And finally, tertiary alcohols have carbon atom attached to hydroxyl group that is also attached to 3 other carbons. And again, a couple of examples are shown here. And as in previous example of secondary alcohols, one in the middle is condensed formula and one on the right is shown as a line formula. Common names of alcohols are descriptive, which means that alcohols are named by naming alkyl group that is attached to hydroxyl group. And so we list alkyl group, and then that's followed by word alcohol. So descriptive names really means we describe the molecule. When naming alkyl group, of course, we use common prefixes, S, T, iso, cyclo, and 2 words, word for alkyl group and alcohol, are written separately. So here are some examples. First example, methyl group attached to hydroxyl, so that's methyl alcohol. Next we have propyl group attached to hydroxyl, so that's propyl alcohol. If alkyl group is cyclic, of course we will use prefix cyclo, so this is cyclopentyl alcohol. Note name of this compound, this is phenol. That really means phenyl alcohol, but the only name that is used for this compound is phenol. This was a name that was originally given to this alcohol, and it has been adopted as both common and systematic name. And even though we could name this compound in different ways, the only name that we use is phenol, and you need to memorize this name. Another name that you have to memorize is common name for 5-carbon alcohol. Typically we would name this alcohol pentyl alcohol, but when it was discovered by distillation of amylose, and so it was named amyl alcohol. So with 5-carbon alcohol we use word amyl to name that alcohol. So this is amyl alcohol, and you have to memorize this. So trivial name is not pentyl alcohol, it's amyl alcohol. And then if it's branched, we name amyl substituent as branched substituent. So isoamyl alcohol, isoamyl means 5 carbons in total, and on carbon next to last there is methyl group. That's what iso means. Hopefully you remember that. Secondary amyl alcohol means straight chain, and bond to hydroxyl group is on the second or secondary carbon. Now, according to IUPAC nomenclature, alcohols are named first by naming the longest chain that contains the hydroxyl group. We name it as alkane. We drop the final E of the name of the alkane, and replace it with suffix -ol for alcohol. We drop the E to avoid having two vowels next to each other. So here are some examples. One carbon would have been methane. Drop the final E, replaced with OL, it becomes methanol. Next one is propanol, and of course, when chain has more than two carbons, we have to use a number to indicate to which carbon hydroxyl group is attached to. So this is 1 propanol, next would be 2 propanol. By the way, trivial name of this alcohol would have been isopropanol. Systematic name, 2 propanol. Next one is also 1 propanol, but on carbon 2 we have methyl group as a substituent. So this is 2-methyl 1-propanol. So note how we name substituted alcohols. So simply hydroxyl group gets the smallest possible number, and then substituent is named accordingly, whatever number substituent gets. This is 2-butanol. Longest chain has 4 carbons, and on the second carbon hydroxyl group, so 2-butanol. This is 2-methyl 2-propanol. OH group is on the second carbon, and also there is a methyl substituent on the second carbon. Cyclopentanol, so cyclic ring with 5 carbons, so cyclopentanol. This will be 1-pentanol, and one more example of naming a little bit more complex alcohol, so 4-ethyl-2-heptanol. Of course, you can pause the video here and name alcohols on your own and compare these names with names that are provided. Ethers are another class of compounds that can be considered to be derivatives of water. In an ether, both hydrogen atoms of water have been replaced by alkyl groups. Now, when it comes to classification, in case of ethers, we don't use terms primary, secondary, tertiary. Instead, we classify ethers as symmetrical when the two alkyl groups are identical, and unsymmetrical if they are different. So ethers are simply classified as symmetrical and unsymmetrical. When it comes to nomenclature, according to IUPAC nomenclature, it is actually considerably less common. Much more common is trivial nomenclature, and we'll cover that next. But according to IUPAC nomenclature, ethers are named as substitute alkanes, and a substituent is alkoxy group. So alkoxy, which stands for alkyl oxy. That means alkoxy. So longest chain is alkane, and whatever is substituent is named as substituent. So in this first example, we have 2 chains attached to oxygen, 1 carbon and 2 carbon chain. 2 carbon chain is longer chain, or the longest chain. So that's the root of the name. That's the parent name. So that's ethane. And then methyl is attached to oxygen. We name this as methyl oxy or methoxy. So compound is methoxyethane. If longest chain, parent chain, has more than 2 carbons, we'll have to use a number to indicate to which carbon alkoxy group is attached to. Note that the 2 substituents are identical. Simply one is named as the parent chain and the other one as alkoxy substituent. So this is ethoxyethane. And this third example, longest chain is propane, and actually you can identify propane chain in several different ways. 3 chain, longest chain of 3 carbons. On the second carbon, the middle carbon, we have methyl group as a substituent and also methoxy. So we have 2 substituents, methyl and methoxy. Methoxy is listed first alphabetically. So this compound is named as 2-methoxy 2-methylpropane. So that's IUPAC nomenclature. It's less commonly used, but when ethers are more complex and they are larger, we have to use IUPAC nomenclature. Common nomenclature of ethers is used almost exclusively. It's used whenever possible, and we use systematic nomenclature only when we have to, when ethers are really complex. If ether can be named using common nomenclature, we will use common name. Common nomenclature of ethers is descriptive. So we describe the molecule, which means we name one substituent, we name the other substituent on the oxygen, and then we use word ether. And 3 words, 2 for substituents and word ether, are written separately. So here are some examples. First one, substituents on oxygen are ethyl and methyl group, so this is ethyl methyl ether. Next one, two substituents are identical, so we use prefix di. So this is diethyl ether. When two substituents are identical, according to common nomenclature, we should use prefix di. Frequently, this compound is simply named as ethyl ether. Rationale is that ether must have two substituents, so if we name only one and list only one, that means two substituents are identical. And that's frequently used in industry, and frequently this compound is sold as ethyl ether. But correct common name is diethyl ether, and for any such ether that has two identical substituents, you should use prefix di. Next one has a little bit odd substituents you haven't seen before, allyl and vinyl. Don't worry about them now. They are listed here because you are going to encounter these substituents later in the course. And then you may want to review nomenclature of common classes of compounds and to know how to include those substituents in the nomenclature. So this is really here because you will need it later in the course. So don't worry about allyl and vinyl substituents right now. If substituent is cyclic, of course you use prefix cyclo, and again alphabetize it. So this is cyclopentyl ethyl ether. Another example is T-butyl or tertiary butyl methyl ether. Again, butyl before methyl. And final example has phenyl substituent. That's benzene ring. So benzene ring as a substituent is phenyl. The other substituent is propyl. When you list them alphabetically, this is phenyl propyl ether. So those are common names of ethers. This completes our study of nomenclature of alcohols and ethers, and next we will examine nomenclature of amines.